Last couple of the days we have been trying to understand the behavior of a falling body. We divide them in three types. Dropping when the initial velocity is 0, throwing up when the initial velocity is greater than 0, and throwing down when the initial velocity is lesser than 0. Today we're going to try to understand the behavior of a falling body when you throw it down with initial velocity less than 0. Alright, so let's dive in. To table initial velocity, we're gonna, this is object thrown down. Thrown down with initial velocity 3 meter per second. So initial velocity 3. Time we list as 0, and then we're going to find the displacement, and then we're going to find the distance, and then we're going to find the velocity, and we're going to find the speed, we're going to find the acceleration due to gravity, and then we're going to find the magnitude of acceleration due to gravity. We're going to do it for 0 second, 1 second, and 2 second. However, we're going to keep the initial velocity 3. That means I'm gonna drop this pen with initial velocity 3 meter per second down. This is what I would do to examine the behavior of a falling body when I apply 3 meter per second down. Alright, so this is 3, 1 second, 2 second. Okay, 0 second. At 0 second, the displacement is, of course, 0. So the absolute value of 0 is 0. Velocity is -3. Okay, at 0 second, the velocity is -3. How did I get that? Velocity, remember, you have to use this formula. Vf is equal to Vi plus At. So Vf is equal to, this is -3 because that's the initial velocity. Since I'm throwing it down, the direction is to the south. Direction is to down. So south or down is negative. Get it? Okay, -3 plus the acceleration due to gravity. Today we're going to use g is equal to -10 meter per second square. Alright, so -10, and the time is 0. So yeah, velocity at 0 second is -3. So speed is 3, acceleration is -10, and magnitude of acceleration is 10. Very nice. Now we're going to try to find out what happened, the displacement at 1 second. So let's find out. Displacement is VIT plus half AT squared. So VI is -3, T is at 1 second plus half, and acceleration due to gravity is -10 and 1 square. So the displacement is, you have -3 plus 2 goes to -10 5 times, so you have -5. Okay, so displacement is -8. Okay, so I'm going to write -8 over here. So distance then 8. Now I'm going to find the velocity. So velocity is Vi plus At. So Vi is -3 plus A is -10, and T is 1. So Vf is equal to -3, -10. So Vf is equal to -13, as you see that. So I'm going to write -13 over here. Okay, now speed is 13, acceleration due to gravity is -10, and magnitude is 10. Now at 2 second, displacement is Vit plus half At squared. So now displacement Vi is -3, T is 2 plus half, A is -10, and 2 squared. So D is equal to -6. So 4. So This is 4. 4 times 5 is 20, negative 20. So displacement is negative 26. So negative 26. So distance is 26. Now for the final time, you're going to find the velocity at 2 seconds. So VF is a VI plus AT. So VF is equal to negative 3 plus negative 10 and time 2 seconds. So BF is negative 3, negative 20. So 23. Velocity is negative 23. So this is 23, negative 10 and 10. All right. So now we completed our table. Now we gonna do DT, VT, and AT graph.